Hello everyone, I'm Karthik. Today I'm going to give my project review on Amazon Prime EDA. This is the summary that shows my project review, what I have done and what the insights I have found. This is my GitHub link for my Amazon project. In the problem statement, we are going to find the key trends that influence the subscription growth of the Amazon Prime dataset. I'm importing standard libraries, pandas, numpy, matplotlib, and seaborn for uh, graphs and visualizations. I'm ignoring warnings because I'm getting a lot of warnings, so I didn't want to highlight them. And I'm importing AST and word cloud to show a specific graph for a word cloud graph. I'm loading my two data sets. One is titles and the other is credits. When merging these two data sets, it is giving a lot of unwanted rows because of duplicates. It is creating rows when merged normally in a inner way or left or right or a full outer. It is giving a lot of unwanted rows. It is giving 1,24,000 rows with all the data same, and it is only changing one value with at the actor name. Because of the actor name, it is creating a duplicate row. I didn't want this to happen, so I wanted to combine all those and put those character names in a single tuple and generate the row. I specified those for I grouped those actors and the directors because of which the duplicate rows are forming. I wanted to put that in a list and then generate. Because of that, I could only generate only 9,800 rows. I minimized a lot of rows, and as we can see that the actor names and actor characters, director names, all these will be giving as a list. Because of this, I reduced so many rows. And coming to the dataset information, most of these are non-null values, and most of them have uh, full values. They don't have any null values apart from very few columns. And as we can see, I tried to find out duplicates, and there are only three duplicate rows when I used this formula, this kind of merging. If when I tried to merge as a normal merging, I found more than 500 rows as duplicate rows. I didn't want to waste all that data, so I used this method. I didn't want these three duplicate rows, so I deleted these three duplicate rows because I don't want the uh, accuracy to drop. After dropping the duplicates, I have 9,868 rows and 18 columns. I wanted to see what is the how which rows have the duplicate values and the mean of the duplicate values, because I wanted to see whether I should delete the row or impute the row, or impute it with the mean or median. So I wanted to find the mean. So whether it's greater less than 3% or greater than 25% to include the specific kind of missing value type. As we can see, I also showed a chart to see how many uh, to show visually what are the null values that's there. This is what I have mentioned in the description about my dataset, also about what I've seen and what are the null values that are there. And coming to my columns, these are the common columns that the both combined merge DF has. I'm describing my datasets columns. Few columns are float type and integer type, and few columns are object type. So I've described both of them separately. I didn't want it to merge and mix match both in the single place, like including all. So I described only one type at a single time. These are all the descriptions of the columns that I have, all the 18 columns, the unique 18 columns. And I wanted to check what is the unique count cardinality value for each column. Most of them have different values for the columns. And in the data wrangling, I wanted to eliminate first things. What we have to do, what I wanted to do was eliminate null values and replace all empty values with something. Most of the movie type shows has seasons as uh, empty value. I wanted to fill only that is a movie type with that seasons to be as 0, because which type has a show or a TV series can be more than one or more than two. So I wanted to show only movie type seasons to be 0. So I used that here. And I wanted to perform actions on seasons. So I converted that data type from float to integer data type. And in the IMDb column, I changed that no values with a random value, because I will not be using. However, I won't be using these IMDb values for any kind of visualizations, but I didn't want to leave it as empty and show null values. So I put random TTTT as a value and describe it. And these four columns are the columns that is to be handled, because most of these have less than the 30%. So I am trying to impute that with the medians. These four columns are IMDb score, IMDb votes, TMDB popularity, and TMDB score. These four values can be used for data visualization and insights. So I wanted to include and impute them with their medians. All these columns are filling their null values with their medians. And if there is any description, we won't be using description for the insights. So I've been uh, converting the null values in the description column. If there is any empty column in the row, I've converted that into no description. And I've replaced any age certification values. Most of these are TVPG, R rated, and TV13. If there is any kind of blank that is there in the age certification column, I converted that to unknown, because if we are wanting to show any kind of insights also, we can see what kind of segregations are there, and we can eliminate the unknown section to find out all the other values. So I filled that with unknown section. After that, I tried to check if there are any null values, and I found out that there is no 0. And this is the merged data frame after doing all that data manipulations. As you can see that most of the age certification values are unknown. The blanks are filled. And yeah, for now, that's all we can see from here in the head. And I wanted to edit and show these values in the if I wanted to edit these values in the Tableau or Power BI, I wanted the clean CSV values. So I wanted to download this one. And these are all the manipulations that I did, that I have told specifically right now. These are the data visualizations that I wanted to show. The first chart is a pie chart that shows the different types of show and what is the percentage of show type in the Amazon dataset. 86% is a movie data type and 13.8 is a show data type. And the second chart is the seasons of TV. I wanted to segregate the shows based on the number of seasons. As we can see that the number of, and I wanted to eliminate zeroth. I wanted to start the count from one and not zero. So I wanted to check only the show type and not movie type, only the show type and count. At show type will be at least one. So I have shown the count of each seasons. As we can see that we can see that it is max till like 5 seasons. Like number one season is having the most count, and 5, 6, 7, or 7 is the max value for the seasons for any show. And the third visualization chart is the number of releases per year. It started from 1910s, the releasing of a show or movie in the Amazon dataset, and as we can see that there is a significant spike from 2020 to 21st century, and majorly from 2010s, as we can see that the spike, and the most releases are in the year 2021 with 856 shows or movies. And this is what I've told about the word cloud. I wanted to see what kind of genre that is more in that data set, and that is available in the Amazon Prime. With this, we can see that documentation, drama, comedy are majorly in the top section, and there are other sections, other genres also, like drama, family, horror, sci-fi, thriller, action, but in lesser count. But most of the shows are filled with these genres: comedy genre, drama genre, documentation genre, drama genre, European genre, action genre. And coming to the fifth chart, I wanted to show a side-by-side chart of both IMDb score and TMDb score. As we can see that the spike is highest in both at 6 points, because I imputed the values with their median, because I didn't even if we have any outliers, I didn't wanted to affect the values of the median or mean. So I imputed them with IMDb scores, because 6 was the highest IMDb score with the median. We got the peak over there, and from 5 to 7 is the highest values from with the highest frequencies. The same with TMDB score as well. And coming to the sixth chart, I wanted to see the top 10 production countries. Ba- by default, it will be US, because as we know, the Hollywood production house is a very, very big production house, and it has productions from years and produces a lot of movies. And next comes India with 1,000 movies, but there is a significant change with 4,000 different movies as a gap. And if we ignore United States, and the other ones fall in place with their gradual decrease for the top 10 production countries. And the next chart shows the uh, chart for the duration of each movie. This is a scatter plot, and I also wanted to show the average time, the median IMDb score. All the blue ones show the show type, and the orange one shows the movie type. And as we can see that in the duration of minutes, most fall under 50 to 150 minutes for a show, and for a movie. And for show, it's either a half an hour show or a 1 hour show. And the median values are also mentioned here. For a movie, it is 6.1, and for the show, it is 7.1. And coming to the next chart, I wanted to see the top 10 directors based on average IMDb score. As we can see, Digpal Lanjekar has the most IMDb score with 9.9, and most of the other one, T.S. Suresh Babu is the director from India, and Gnanavel. These directors are from India, which who has 9.3 as their average IMDb scores. And The other ones also with the average IMDb score is 9 in the top 10 IMDb ratio and scores. And this is a common KPI I wanted to show, which has season count of movies. How many movies are there that is having a movie count that is 8,511. So these are the specific kinds of charts that I wanted to show, and the business objective and conclusion that I wanted to give based on my analysis and insights based on the charts. Thank you.